What is it? Now, look, Wikipedia is essentially every man's encyclopedia, and while it does help with some of the general things, most of the time it has some fairly correct information, but I'd like to advise you from using Wikipedia as your main technical reference, because there is a lot that can be put in. It's not peer-reviewed, and it is not really, I mean, I think it doesn't hold much water. All right. Anyway, the key things: produce, transform, transport, and properly use chemicals, materials, and energy. There are different ways of defining it, and I must admit this definition isn't too bad. But when you look at it, whenever we are making something, right from your average cooking, whatever a level of sophistication, maybe it's highly unsophisticated where you chuck something on a barbecue and just heat it on the naked flame or the plate, or something much more sophisticated where you got a blend of spices and there's some intricate cooking involved. Whatever you do, it's still chemical engineering. You are transforming, you're creating something. And chemical engineering affects practically everything that we do. The toothpaste that we use in the morning, the toothbrush, the fact that we can we can get to work by public transport, by motor car, by bicycle, whatever it is, everything is dependent on chemical engineering. Because in reality, we are the only ones who understand the key processes to make other things. So I have essentially jumped the gun a little bit by going through these points already. Oil and gas, pulp, paper. I read the morning paper, of course. That is now changing. I am still old-fashioned. I do like to read the paper when I get a chance. And so essentially on the weekends, that's my little treat, having the printed form of the paper. We use paper for printing. Chemical plants manufacture a raft of chemicals, including detergents, paints. Manufacturing. We are manufacturing, and again, it goes back to lots of things. Adhesives, for example, pharmaceuticals, your fertilizers. So practically you name the area, we are there. And therefore, it is, because it is so vast, it is also extremely diverse, and it has led to a large number of specializations. But without any prejudice, I got to make, one of the areas that I think will allow you to move fairly broadly, I would say, is really oil and gas. Because with oil and gas, one of the beauties of oil and gas engineering is that it includes practically all the major types of unit operations. What is a unit operation? A unit operation is generally a physical change. Generally, I'm not saying always. And it also includes a couple of unit processes where we talk about reactions. So, understanding the principles of oil and gas, process engineering in the context of oil and gas, does allow you to move and appreciate. However, when we move into the realm of pharmaceuticals, we're looking much more at the molecular level, the thermodynamics. How do we actually deliver a drug? How do we change the drug shape, the molecule shape, so that it can achieve something? So there are all sorts of interesting questions that we begin to ask when we go to pharmaceuticals. Pharmaceuticals, much more batch. When you go to things like fertilizers, these are essentially hardcore processes. So pulp, you've got a little more solid handling, you've got a solid handling, filtration type of processes, but you have less reactive processes. So there is quite a range that has led to a level of, a level of specialization. Now, there are a number of variables that we use. Once again, I do not expect you to memorize all of these overnight. But it is a good idea to make these your friends. I mean, you've got pressure, volume, number of moles, the gas constant, temperature, specific heat. Now, please be aware that when I've got, for example, any variable with, let us say, a dot on top like this. When I've got the M with the dot on top, it refers to the mass flow rate. So there are a number of types of variables. Look at that here, for example. We've got M and N, small m being the mass, capital M being the molecular weight. So, look, get familiar with these. I don't think it is wrong to say that, as they say, these variables are your friends.